Hi, today we're going to do transformations of functions. So last class we talked about the basic parent functions. We said there were 6 of them, 5 of which we are going to apply transformations to. And here are the 6 transformations. We said linear was y equals x, and that was a straight line. That one we're not going to do transformations to. Quadratic we said was y equals x squared every time there's an x squared, and that is U-shaped. Cubic is y equals x to the third, and that is like a parabola going up and a parabola going down. Notice the resemblance in the two shapes and the resemblance in the characteristics of the function. Cube root is y equals the cube root of x versus square root is y equals the square root of x. They also have similarities. This one goes up and over, but this one goes up and over and down and back. And the absolute value is v-shaped, and that is y equals the absolute value of x. So those you need to know. We had to pick special values with our square root and our cube root. We wanted right here perfect cubes, and right here perfect squares, and those could only be positive and 0. So a quick recall from Algebra 2, vertex form. Remember, vertex form helps us identify the vertex immediately. If you had a problem like this, you could say the opposite right here is going to be what the x is going to be, the new vertex. The same value as this is what the y value is going to be for the vertex. So it's h comma k. So for example, in the second problem here, it's the opposite of this for the x, so a positive 3, the same as this for the y, so a positive 7. This is where your vertex would be. This essentially was just applying a transformation. In the transformation, this first number here moved the x in the opposite direction. So what I mean by that, here's the x-axis. It was a minus 3. Typically, you'd go minus 3 this way, but you go the opposite direction, go plus 3 this way. So look what happens. If your vertex starts here and you go plus 3, what happens is you're moving right 3, and you are also taking x and adding 3 to the value. We're going to come back to that in a minute. If you take a look at this 7 right here, we said that affects the y value in the same direction. So what that means is the y-axis goes up and down. So because it's a plus 7, we will go plus 7. So we would go, instead of 0, we would go all the way up to that value of 7. So 3, 7 right here would be our new vertex. Or we would be going up 7. Now, if you take a look at this equation, this is a generic equation. I wanted to show you the last slide because all transformations hold the same features as they did with the left and right and up and down. The A, the B, the H, and the K are all going to apply transformations. We just talked about what is going to happen with this H value. This H value is going to affect the X value in the opposite direction. So this is going to go, x-axis goes right and left, so it's going to go right or left in the opposite direction. We also said this k value, which is on the outside, just like the y is on the outside, affects the y value in the same direction. So this, because the y-axis goes up and down, is going to go up or down in the same direction. And that's what it means verbally and what it means algebraically, because sometimes it's going to be easier to do this algebraically, especially when we have a shrink or stretch. What it means is we're going to do a y plus whatever that k value is. And this is going to be a plus or minus, depending upon what the sign is. And it's going to go in the same direction. And this is going to be an x plus or minus the h value, but again in the opposite direction. Okay, and I'll explain that a little bit more in the next few slides. Now, this a value is going to be a shrink or a stretch. It's going to be a shrink if the absolute value of a, so not looking at the sign, just the number, if that is less than 1, it's going to be a shrink. It's going to be a stretch if the absolute value of a is greater than 1. So that's going to affect how wide your parabola or your function is going to be. Because this a value is in the outside, just like this k was on the outside, 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 outside. And what I mean outside is it's not inside. It's not inside the parentheses or inside an absolute value or inside a radical. Everything that's outside that I have shaded in yellow is going to affect the y value in the same direction. So in other words, this a, because it's on the outside, will affect the y in the same direction. So it's going to be a times whatever the y value is. Okay, so algebraically, it means a times y. Algebraically, the k means y plus or minus k, because those are on the outside like the y is. But on the inside, we have the b value and we have the h value. And everything inside affects the x value, and it affects it in the opposite direction. Okay, everything outside is in the same direction. So if there were a shrink or stretch of the x value here, it wouldn't be multiplied as this is multiplied and this is multiplied. It would be the opposite. It would be divided. Now the good thing is you don't have to worry about that. All you need to worry about is everything else that I have written down here. So we're going to give this a try, and what we're going to do is we're going to describe the transformations, and then we're also going to list what happens with the x and the y values. So a little bit different than what the directions actually say here. It also says to name and sketch the parent function. We are going to do that because we need more practice with that. So first of all, if you look at the parent function, you need to ignore every number that's added or subtracted, multiplied, and divide, except the variables. So we have our f of x or our y, and we have our square root of x. This is obviously square root, so it's a square root function. And we know square roots, or hopefully you're starting to realize, square roots go up and over. Square roots also do not have negative values if we're coming up with a table. So I'll just do this one. If we are doing a table, we have to start at 0, and then we want perfect squares because that's the only way we can take the square root. So we do 1, 4, and 9. That would be our table of values. Okay, that's what we did yesterday. Now today we're going to apply the transformations or describe the transformations. So 4 over 3, if I plug in 4 divided by 3 in my calculator, I get 1.3 repeating, which is definitely bigger than 1. So that is going to be a stretch. So we're going to write a stretch of 4/3. And then the other thing that I don't have circled here is that plus 2. Well, the plus 2 is on the outside, just like the y or the f of x is on the outside. So it's going to affect the y value, and the y-axis goes up and down. So therefore, that's going to move it in the same direction, 2 units. So it's going to go up 2. Now that's the first thing you're going to do. The second thing you're going to do is you're going to tell me how mathematically this works. So a stretch of 4/3, we know that that also affects the y. So it's just taking y times 4/3. The up 2 also affects the y. It's going to be y plus 2. All right, so what I'm looking for on all the problems then is just that. You're going to tell me verbally what would happen, and then you're also going to tell me mathematically how you would get that. So if you take a look at the next one, it said is f of x equals all that. This negative in the front works just like a negative it did before. It's a reflection. So this right here reflects across the x-axis. Reflects across the x-axis. That's how you would say that. And let's just continue and do all the transformations. So everything is a transformation except the y and the x. So there's the reflection. This right here affects the x because it's inside with the x in the opposite direction. So that is going to go left 1. And this right here affects the y in the same direction. So that's going to be up, or I'm sorry, down 8. Down 8. Now, algebraically, what this would mean is this. So again, everything that's outside, so this is outside, is going to affect the y in the same direction. So this is going to be a y times a negative 1. That's the reflection. and this is going to be a y plus an 8. And inside is in the opposite direction. We said, so this is going to be an x minus 1. All right, next one. The next one is somewhat tricky because it has a negative and it has the 1/3. Remember, it's the absolute value of this number. It's only this number. It doesn't include this sign. This sign right here is a reflection across the x-axis. Across x-axis. Oh, I see. I forgot to put the x up here. Okay, it's a reflection across the x-axis. And then the 1/3 is the shrink. So it's a 1/3 shrink. I should have written shrink of 1/3, but that's fine. And then this right here affects the y in the opposite, same direction, sorry. So this is going to go up 5. That's the up and down. Now, algebraically, mathematically, this negative is going to take, because it's on the outside, it's going to take the y times -1. And there's nothing inside attached to this cube root function. So there's nothing that's affecting the x's. This affects the y's, so this is y plus 5. And this 1/3 that's right here also affects the y's, and that's y times 1/3. Or you could just say y times a -1/3. You could actually group those together. I guess what I didn't do with these problems is I didn't do the shapes of them. So this is a cube root, and it goes up and over and down and back. This one here was cubic, and it goes up and down and back. And we did the square root. All right, feel free to work ahead on this. I'm going to name these first so I don't forget. This is the absolute value, and we know that that's V-shaped. The next one is a cube root right here. Cube root, and cube root functions go up and over and down and back. And this is not the squared, remember, this is quadratic. Quadratic, and that is U-shaped like this. I'm not going to talk about the x values. Now let's apply the appropriate transformations to each of these. So here's the y. Y is on the outside. Everything on the outside is affected by the y. This is by a y, this is by the y. Everything on the inside, which, by the way, there's nothing on the inside but the x, so nothing's going to affect the x, but that would affect the x in the opposite direction. So the 1/3, it's less than 1. That is a shrink of 1/3. So we have a shrink of 1/3, or it's a y times 1/3. And then we have a plus 2. So that is going to be an up 2, or a y plus 2. Okay, for the next one, remember we're going to take the negative separate from the 3. So the negative is a reflection across the x-axis. And the 3 is a stretch this time. Stretch, oops. Stretch of 3. And what that means is it's going y times -1 and y times 3, or you actually could combine those together and say y times -3 right there. And the last one has multiple transformations. So let's just start with everything that affects the y, so everything on the outside. The 2 is on the outside, the 1 is on the outside. So this is going to be a stretch of 2, because it's bigger than 1, and then it would go up 1. Or we could say y times 2 and y plus 1. And the -3 is inside, so that means it's going to go right 3, opposite direction, so right, or x plus 3, opposite direction. And now I would like you to pause the video and actually try all of these, starting first with the function names and a sketch of the shape. And that's what you should have for the sketches and parent function names. And you can now continue with the transformations, both verbally, and then also algebraically. And there you have it for these problems. The hardest one was probably the second one because it had a lot reflection across the x-axis, which is just multiplying the y's by a negative. Shrink of 1/3, which is multiplying the y's by a negative by a 1/3, which you could combine that into 1. The -7 was a y -7 or down 7. And the +5 underneath or inside is left 5 or x -5. And then you can check the other ones as well. All right, that's it for today. You already named the family functions on your worksheet. You're on the 1.6 worksheet. So today you just need to go through and just describe the transformations both verbally and then algebraically as well in the space provided. Goodbye.